On the previous page, we were talking about an example where we found a p-value, or we talked about a p-value that was found by someone else because at this point we don't know how to find a p-value, but we will someday. But we said our p-value in the previous page was, I believe it was 0.0023. I think it was zero. Okay, anyway, so we said, oh, that's a small p-value because the probability then, if we change it to a percentage, would be 2.3%. That's not a great chance. But what if it was a little larger than that? Would I still say that's a small p-value, quote unquote, and I'd still reject the whole null hypothesis? So now we're going to look at how small does a p-value have to be in order to be able to reject the null hypothesis? Because if it was twice that, maybe if it was 5% p-value, would that be small enough, or is that kind of more normal and I would not reject the null hypothesis? That's what we're going to talk about on this page. How small does the p-value have to be to reject the null hypothesis? A small p-value indicates that it is unlikely that the actual sample data came from the population described by the null hypothesis. But because you know that the data did come from that population, it must be that the null hypothesis is wrong. More precisely, a small p-value says that there is only a small chance that we will randomly select a sample with results at least as extreme as the data if h sub 0, or the null hypothesis, is true. The smaller the p-value, the stronger the evidence against the null hypothesis, h sub 0. But how small does the p-value, where's the cutoff point? P-value smaller than blah would make us reject the null hypothesis, but anything larger than that, we would not reject it. In practice, we often compare the p-value to 0.05. So that's kind of the cutoff point. We'd say if p is 0.05, that's 5%. You have a 5% chance that that happens. That's kind of where, if it's less than that, I'd say it's unlikely. More than that, I'd say it's fair. It could happen. It's likely enough to where I wouldn't just reject the null hypothesis. I might do more research and look into another sample maybe. We reject the null hypothesis in favor of the alternative hypothesis if the p-value is less than or equal to 0.05. So less than or equal to, I'm going to change this to a less than. P equal to 0.05 is fine, but less than that, also good. In those cases, we reject the null hypothesis. Why compared to 0.05? It's just a convention to define a cutoff to identify results that are highly unlikely to occur when the null hypothesis h sub 0 is true. By comparing the p-value to 0.05, we are saying that 5% of the time when h sub 0, the null hypothesis, is true, sampling variability will produce results at least as extreme as the data we observed in our study. It is possible that a random sample will have this much error when h sub 0, or the null hypothesis, is true, but it's highly unlikely. Therefore, when a real-life study has a result that is highly unlikely to occur in random sampling from a described by the null hypothesis, statisticians are comfortable concluding that h sub 0, or the null hypothesis, is probably not true. The number 0.05 is called the significance level for the test. Are other significance levels used in statistical practice? Now, that's a good question. Occasionally, researchers use significance levels other than 0.5. In particular, if rejecting the null hypothesis will be controversial or expensive, we may require stronger evidence. In this case, a smaller significance level, such as 0.01, is used. As with the hypotheses, we should choose the significance level before collecting data. It is treated as an agreed-upon benchmark prior to conducting the hypothesis test. In this way, we can avoid arguments about the strength of the data. The symbol we use for the significance level is alpha. Here, they show it. It's a lowercase letter a, alpha. We sometimes refer to the significance level, it looks almost like a fish, right? As the alpha level. We call this value the significance level because if the p-value is less than the significance level, we say the result of the test showed a statistically significant difference. The difference is not attributed to chance or variability. So yeah, the alpha is called the significance level because it's the point at which a difference in the sample compared to the null hypothesis would be significant enough to make us change our thoughts about the null hypothesis. Maybe our null hypothesis is not right, I guess, is what we're thinking here. And they've kind of summarized it here. If the p-value, if the p-value is less than or equal to alpha, we reject the null hypothesis in favor of the alternative hypothesis. But if the p-value we find is greater than alpha, whatever your significance level is, like we said, it's usually 0.05, but sometimes you want it to be smaller than that, like 0.01. Whatever your alpha is, you chose it. If the p-value is greater than alpha, we fail to reject the null hypothesis, and we just stick with the status quo and keep going with the null hypothesis. Statistical significance, another way to describe unlikely results. When the p-value is less than or equal to alpha, we also say that the difference between the actual sample statistic and the assumed parameter value is statistically significant. In the previous example, the p-value is less than 0.05, so we say the difference between the sample mean, 75 megabytes, and the assumed mean from the null hypothesis, 62 megabytes, is statistically significant. You will also see this described as a significant difference. A significant difference is an observed difference that is too large to attribute to chance. In other words, it is a difference that is unlikely when we consider sampling variability alone. If the difference is statistically significant, we reject the null hypothesis. Other observations about stating conclusions in a hypothesis test. We have to be very careful in how we state the conclusion. There are only two possibilities. One, we have enough evidence to reject the null hypothesis and support the alternative hypothesis. On the other hand, if we do not have enough evidence to reject the null hypothesis, then there is not enough evidence to support the alternative hypothesis. Only one of those can happen. If the p-value in the previous example was greater than 0.5, then we would not have enough evidence to reject the null hypothesis and accept the alternative hypothesis. In this case, our conclusion would be that there is not enough evidence to show that the mean amount of data used by teens with smartphones has increased. Notice that this conclusion answers the original research question. It focuses on the alternative hypothesis. It does not say, quote unquote, the null hypothesis is true. We never accept the null hypothesis or state that it is true. When there is not enough evidence to reject the null hypothesis, the conclusion will say, in essence, that there is not enough evidence to support the alternative hypothesis. But of course, we will state the conclusion in the specific context of the situation we are investigating.